A lot of what we're going to do today is review. Okay, we're going to put it into a little bit of a different context, but you've done all of this before. Okay. So some of the problems that you're going to do look like this. If you want to take a picture of this screen rather than writing it all down, you are welcome to do that. And we'll talk about what all the directions mean, how you're supposed to answer these questions, and we'll go from there. So we've talked about degree before. We did that before we went on Thanksgiving break. All right. Degree is, you find the degree of each term, and then the degree of the entire polynomial is the highest degree of the terms. Okay. The one thing we haven't talked about is leading coefficient. Now, most of the time we put polynomials in what's called descending order. And what descending order means is that the variable to the highest power typically comes first, and then we just kind of move down one at a time. And as we've been working through polynomial division, we've checked to make sure that we go down in order. That is descending order. And the coefficient that goes with the very first term is called the leading coefficient. Okay? If a polynomial is not in descending order, you can still find the leading coefficient. It always goes with the variable with the highest power, even if it's not listed first. Now, in this particular case, it goes x to the fifth, x to the third, x to the second, x to the first, and then x to the 0. We're missing an x to the fourth, but they go down. Okay? So this first term, since the variable has the highest power on it, this is going to have the leading coefficient right here. Okay? What is the degree of this polynomial? So what's the degree of this term? What's the degree of this term?
2, 1, 0.
So what is the degree of the whole thing? 5. It's the highest one. Okay? And since 5 is the highest power on the variable, and this is in descending order, meaning this one comes first, the leading coefficient is just 8. You're going to have problems like that, and that's all you're going to have to say. The degree is 5, leading coefficient is 8. Now, the key thing here is in the directions it says, if it is not a polynomial in one variable, explain why. Well, ultimately, if it's not a polynomial in one variable, that means there's more than one variable. Okay? So for part B, is this a polynomial in one variable? No, okay, because I have an x, and I have an x and a y here. So while this may be a polynomial, it is not a polynomial in one variable, and then you have to do is say that. Not in one variable, there's more than one variable in the polynomial. That's all you have to say when it's not a polynomial in one variable. We could still find the degree of this. Okay, the degree is still going to be 2. But in this particular problem, in these problems that you're going to see in 5.3, if it's not in one variable, we're not going to talk about degree. All right, go ahead and do the last one and see what you end up with, and we'll see if you did it right. Is it a polynomial in one variable? Yeah. Okay, what is the degree? 8. Okay, which means what is the leading coefficient? -4. So if you said 3 because it came first, okay, that would be incorrect. Okay. The leading coefficient is always with the variable with the highest power. So even though these are not in descending order, if you were to put them in descending order, this term would end up coming first because it has the highest variable power. Now, please pay attention when I'm talking about the powers. I'm talking about the power on the variable. Okay? We're not talking about just any power. It has to be on a variable. Okay? Are there any questions about that? So that's part of what you're going to do today. Again, nothing really new here. We've talked about degree. Leading coefficient, I guess, is technically new. The rest of what we're going to do today is not new, and it's going to look like you're going to be evaluating functions. Okay? And in this case, we're going to have this function w of x. And the rule basically is -2x to the third plus 3x minus 2. So in this problem, you're going to find w of 5. You'll go through and work that out, and then you're going to find w of -. So let's start with w of 5. Let's do that one first. You guys do that one. What do? I mean, what are the mechanics of this problem? Plug it in where? Yeah, plug it in for x, simplify. Go ahead and do that. So here's your setup. Should have looked like that. One of the concerns that I would have, I bet some of you tried to multiply here, make this -10, which you cannot do multiplication before you do powers. You got to take 5 to the third. 5 to the third has to come first. Okay? So what is 5 to the third?
It's actually 125.
It is. And then you take 125 times -2 and you get?
-250.
And 3 times 5? So here's the next step. -250 plus 15 minus 12. How many had that? Okay. And so then I just go from left to right. And W of 5 equals -247. How many had that? Okay, very good. Right? Nothing new there. Okay, so part of this problem asks for W of 5. It also asks for W of -4. So we have to go through that process again for W of -4. Let's go ahead and do that. Here's my setup. I plug -4 in for x. So you should 104. How many got it? Okay, good. One more we're going to look at. Makes it a little more complicated, but shouldn't be too bad. All right. Same. 104. So same function. Okay, but instead of inputting a number, we're going to have a variable as an input. So it doesn't work any differently. I'm just going to take a squared and I'm going to plug it in for x. Okay? So I'm going to replace x instead of replacing it with a number like we did for those last two. We're going to replace x with a squared. So go ahead and do that and see what you end up with. One of the things, if you noticed on the other two problems, that I always input it first without trying to do a calculation. Okay, I just straight up come in so you can put the a squared in for the x before trying to do calculations in your head, just to make sure that you've got everything straight. I would do that first if I were you. When I have power to a power, what do you do with those numbers? Multiply them. So this is -2a to the 6th. Can I do anything else with this now? Are there any like terms here? No. They have to be the same variable to the same power. I have the same variable, but they're not to the same power, so they're not like terms. So that's all you can do. Okay, how many had that? Good.